Okay, so I'm really excited about this, and I think it's an important topic, and especially useful for all the work that we're doing. Yeah, I'll just start off with a quick introduction. So I am a research engineer at Microsoft Research, and I work at the intersection of AI and societal impact. Right? I'm very excited about using technology, cutting edge technology, and sort of using that to solve some of our hardest problems. And I've been here about 2 years, and I worked in mental health, and now looking much more directly focusing on AI and societal impact. And so 2 years before this, I was running a company called R2. I ran this for about 10 years. This was in the financial inclusion space. We built software for microfinance companies, NBFCs, banks who wanted to give out loans to small businesses. And their answer to everything was to use more paper, more people, more processes. And we said, you need to get smarter. You're already doing such great work. And so we were one of the first to sort of bring tablets and mobiles into the field way back in 2010. And so over the years, we had disbursed about $1 billion worth of loans, and we impacted 5 million lives. And so I wound down this business in 2020 as gracefully as I could, because I realized that I'm very excited about going deeper into technology and sort of unlocking even more impact. And that's what made me go to MSR, right? Because I have this unique opportunity now to work at the intersection of AI and societal impact. Yeah. That should be okay. Okay, so before we get started, the reason why I want to talk about this topic, because I think it's really important. So almost a month ago, June 25th, this is Andres Pepati, they did a hackathon in the Bay Area where they were discussing specifically AI agents and they were building stuff over there. And one of the things that he said, which was very interesting to me, which was that he thinks definitely there's a direction worth exploring. And he said that you can compete with OpenAI in AI agents because they're new for everyone, right? When it comes to sort of training and building new models, OpenAI is really years ahead because they've already had that head start. But when it comes to AI agents, all of us are sort of on the level playing field, right? So it's literally people like us are right there up to the front and center. Right? So that's where I wanted to. That was the big motivation for this talk. Let's go next. Okay, so I know all of us are here from different backgrounds, right? Varying levels of understanding of tech and AI. So I thought I'll structure this talk as sort of 3 passes at this idea of AI agents, right? So every pass we'll try and go a little bit deeper and build a slightly deeper understanding, deeper intuition, and probably the final stage will also look at some code. Right? So in the first phase, which I call the why phase, I'll try and show you some cool demos so you get a sense of why is this important, why are these AI agents so powerful, right? And the second one, we can go and build some deeper intuition, look at some of the patterns. That'll be slightly short. And in the what section, if you guys are still hanging in there, we can look at some code and go deeper. And finally, I can have a short note about MSR, and then we can discuss whatever you want, right? Look at specific projects, etc. So just facts, right? So the main objective is that wherever you are in your understanding of AI, right, today, you get one level deeper, in that on AI agents, right? Okay, great. So let's go through the first phase, right? So this is a demo. Can you click next? So this is a demo which actually it's called GPT Engineer. What we're doing over here is we're giving it a simple explanation of the game that we want to build. So we all remember the Nokia game about Snake. So we're building a multiplayer game. You kind of describe it saying build this in the browser, etc. And you click enter, and this thing comes online, right? And the first thing it does is it asks, is there anything unclear? Should I clarify some assumptions, etc. So again, you can give it some inputs, right? Clarify its assumptions, and then you can say done, and it will sort of run through and create the entire code to play that game, right? Now, doing this in ChatGPT would have been very hard, right? Just you give it one prompt, then you wait. You have a limitation that only so much output you can get at one time, and if there are errors, right, you'll have to sort of fix it manually. So this is sort of running in like a loop until it achieves your total objective, it will keep running and it will finish. So right now it's got the full game, and then I can open the code and look at each of those files, etc. Right? It's pretty close. It's like 98% there are like 2% errors which you can fix. Right? And then there are simple ways in which we can actually achieve that full 100%. Now this is being done for about maybe say 10 files, right? But there's nothing preventing us in scaling this idea to like real projects, which could be like thousands of files or tens of twenties of engineers. Right? So AI agents can generate full code bases. That was when we saw this, it was like really interesting. Right? Next. Now I can give you another example of AI agents can actually shop and navigate the web. They can literally go around. So this is again from a recent paper. Just click next. The video. Yeah. So what happened here was just press. No, it's playing. It's playing. Just a little slow. Just click play. So over here, what they've done, this came out like about 5 days ago, where they created this environment. They created like a fake Amazon, a fake Reddit, a fake GitHub, etc. And they came up with like lots of tasks, about 800 tasks, and they're looking at AI agents sort of doing each of these tasks. In this case, they're saying, hey, go to my last order and find out what's the status of the last order. So it actually goes, navigates pages, etc., and then comes back saying, okay, your last order is actually cancelled, so it's not going to be delivered. Right? When they put out this paper, they said that hey, only 10% of the time they got it right? So they've created this kind of a sandbox where others can build their own agents and sort of deploy them and see how they can perform and benchmark, right? But imagine if you can give it the browser, access to the browser, it can do pretty much anything, right? It can do pretty much all the work that I do on my computer, right? Which is on a browser. And the previous slide, which is code, right? It don't need. Next. You can also get it to do cutting edge science. This is a project called ChemCro, which was really interesting. What they said was, okay, so my chemistry is weak, so don't judge me on that, but I googled it. So they said, okay, can you build this molecule? What are the steps, right? This is actually the medicine that if you have high cholesterol, you will take, right? So and they did 2 experiments. They ran GPT-4. They said, okay, let's just run plain vanilla GPT-4 and see how does it give it step-by-step actions. It did something. So it said, okay, start from this compound and then do this. And by the time it got to the 3rd and 4th thing, it fell off the rails. It started hallucinating. It made up its own compounds. So when you showed it to like an expert chemist, they said, okay, it doesn't have awareness of the current progress, like science has progressed in the last 2 years, right? And it actually does not lead to the product that we want. Then they put their tool where they gave it all these interesting tools, right? Where it could look up Google, it could do, look up the latest publications. It also had something special like they call smiles, which are related to molecules, right? It can really have a deep understanding of molecules, etc. And they said, gave it the same task and it actually did the whole thing, right? And so the human evaluators gave it 10 on 10, whereas plain vanilla GPT, they gave it 1.5 on 10. Right? And this is cutting edge science, and there's like another example of this in another aspect of science, right? So they're really powerful where they can do things which have never been done before as well. Right? And this was a very fun paper. This came out earlier, I think in February or so, where AI agents can actually simulate human behavior. So a group, I think at Stanford, what they did was they created 25 characters, right? These little guys you see, and they gave each of them like a bio. Like this guy is a baker, he has a wife, he has a son, he likes to keep his customers happy, right? And they sort of give everyone a role in the game. And so there are 25 roles like this, right? And if you go to the next slide. So what happens is every half an hour interval, they ask each of them, what are you doing? Right? So basically, ChatGPT is sort of figuring out what are they doing at this time. At 6 o'clock, what is everyone doing? It says, okay, this person is sleeping, this person is sleeping, oh, this person is awake, this person is cleaning the house, this person is brushing their teeth, right? And so they go on like this 6:30, 7, so on and so forth. They actually, what happened was these little characters started talking to each other, right? And the other interesting thing they did, so this whole game is playing out on Feb 13th, right? It's Monday to Feb 14th, which is Valentine's Day. So the researchers told one of the people that, hey, you're throwing a party on the evening of Feb 14th, right? And if you go to the next slide, that information actually spread to the other people. And some people asked other people out, some people who were already couples, they went together, right? And so at Feb 14th at 5 p.m., you suddenly see a lot of agents are there together, attending like this Valentine's Day party, right? So it was like actual social behavior where they were asking each other out, and they were, I think one person was standing for elections and he was trying to get people to vote for him, etc. That paper is really fun, but what is interesting from this is that you can also do role play and actually simulate human behavior. Right? So imagine if you're trying to do like a very large scale project to study their impact, you can actually sort of create this kind of a setup. Right? Yeah, you go to the next one. Yeah, and this I think is probably the most fun. So this paper is called To Infinity and Beyond. Right? So where a bunch of people from Pixar and Oculus and some other places where they work, they said, okay, a lot of these shows have ended, right? Like South Park, maybe Game of Thrones, etc. What if we could actually continue them? What if we could get AI to simulate these roles? So you give them a scenario and you say, okay, generate dialogue, and then they also generate the images for that, right? And they actually shot like this 30-minute episode of South Park. So you just play it, and maybe I can fast forward. So it starts off in this place. So you can see there's Harrison Ford, there's Elon Musk, there's Mark Anderson, and they give a prompt saying that Cartman, right, has this idea that he wants to create a deep fake streaming website called Quippy, right? And so they give this scenario, and they have like other interesting things like Elon Musk has taken some of these characters already to Mars, and has been running a deep fake program on Earth that nobody knew about it. So we can maybe fast forward a little bit, but it's got. So instead of asking ChatGPT to just generate a script, which would be very boring, they're actually simulating it. And then from that simulation, they're like generating dialogues and just give me. We'll just give it to them. Let's see. Not actually fun, but you can. So he's saying Cartman heard of this Screen Actors Guild strike. The kids are worried that their favorite shows will not be coming anymore, and he comes up with this idea of deep fake streaming service. Okay? And so this episode is called Creepy Coolly.
Does that mean there won't be any new shows coming out? Exactly.
So they use the images from the show. They're using stable diffusion to regenerate the scene in the background, the character, and then they're using audio, text to audio to generate that text, and all of that. But it's good fun. I mean, it gets a little boring because they like everything research. But it's fun to see that this is possible. And what they're doing is they're actually coming up with 3 shows later this year. With right now they've like not got rights for the South Park. Right? They're just doing it for research purposes. And normally a watermark, but they plan to actually create shows like this. Yeah, pretty much. Okay, so I talked a lot about all the positive stuff about AI agents, right? Now, obviously, it's not all hunky dory, right? So the challenges, in terms of challenges, costs, a massive cost for these things, right? So every call to GPT, let's say, works out to about 0.2 of a dollar, right? So $0.2 at 80 rupees is like 16-20 rupees, right? And if you run this, like some of these tools like AutoGPT, etc., take 50 steps to do the same thing, right? So in that case, you're talking about $14. So if you run this, you're going to be spending a lot of money, which could be a deterrent in lots of use cases. Right? Now, it could be worth it if you're doing something really novel and you can use that, and you don't have to spend it again. It's like the investment cost, right? Instead of getting a developer, spending $14 on them, you could do this. So there are places where it can make sense, but there is another challenge. Click next, where so what this article talks about is that the development and the production environment are merged. What that means is that suppose you remember the shopping example, right? So let's say I'm so lazy, I don't want to go to Amazon, and I just want to tell my bot to buy like my toothbrush or toothpaste, right? So the first time I'm building this, it's going to spend $14. But the next time I want, let's say, batteries, right? Similar task, it should not spend $14, but it'll actually spend again $14, right? Because it's not generating code; it's sort of going to that page, making a decision where to click, and all of that, right? So these are some of the challenges of these AI agents, but they can easily be solved again because you can, instead of saying, okay, hey, click on that, generate a piece of code which is free to execute. Right? So there are ways to overcome this, but yeah, it's an interesting space that's going to evolve very rapidly. Okay. So I think we're done with the first pass. Was this okay? We're still in there? Yeah? Okay, great. So now the second pass, we'll actually go a little bit deeper into how is this happening, right? So I think you would have figured out like this is the large structure where we're getting the input. If you've ever played with GPT, you would have said, okay, there's an input, there's a language output, and it gives you an output. But instead, in between, we're also going to give it some capabilities like, it can contact the weather or currency and things like that, right? So you pass that and you get some more output, right? And then again pass it to the large language model on the way out, and it will sort of generate the final output, right? It's actually just as simple as this as the pattern. Instead of making one call and getting the right answer, you take that call, put it into this tool and get back this, right? Okay, but this is like a slightly deeper version of what is happening, right? So we call this the agent, but basically it has 4 core components, right? So first part is it has something called as planning, right? Planning is where it takes what your objective is, like you want to go shopping, you want to get whatever toothbrush from Amazon, and it tries to decompose that into a bunch of steps. Go to Amazon.com, search for toothbrush, click on Oral-B, add to cart, pay, etc. Right? So that's what it's doing over here, right? In the planning phase, it's as simple as that. And then the second phase is, second part is tools. Like you can give it access to a browser or search or calculator, things like that, right? So you can give it very specialized tools over here. It could not just be these simple things, it could also be a model. It could be like Vashni model, like, convert this text, translate. It could also be image models, right? So I have an image, can you tell me what the caption is from this image, and then again process it. Now, and then, so based on this, it takes an action, right? Based on these tools, it takes an action, and then that action is as simple as like what tool to call with what arguments or parameters, and then those tools return some output, and then it again goes in a loop, right? And these are the 3 major parts. So what happens is sometimes it gets stuck. Sometimes it might get stuck in the wrong place. It might have gone in the wrong direction and all of that, right? So that's where we give it somewhat of memory, where we say, okay, in the past you did this, now follow that routine, right? This is how humans also think, right? So humans also plan, and they have some tools which are their hands, legs, etc. And they have some memory of what has happened either yesterday or long term or what we studied in school. Next. So this is what. Yeah. So the self-criticize actually is also a problem. Can you go back? Yeah. So self-criticize is also the problem, where you say, okay, so let's say I want to buy a toothbrush, and it comes up with a goal, right? Now you pass it again to it and say, okay, hey, criticize this. Do you think there's anything wrong in this plan?
But how does it know that something is wrong, or like what objectives are they met?
Yeah. So you said this was the objective. So okay, so this is like a really interesting thing that you can do with GPT, right? So the first time you query GPT, you tell it, you're an expert coder, you're an expert planner, you're an expert movie maker, right? And then the next time you query it, you say, hey, you're an expert critic, and this was generated by a novice programmer, movie maker, whatever, and you say, can you pick up some flaws in it, right? So it'll actually go think about it, and then you can pick up some flaws. So it's really as simple as that. Just give it different personas, and it tries to do that. It's probabilistic. It's probabilistic, so it's not 100% accurate. Yeah. So this was actually a slide that became really popular, a few months ago, called the anatomy of autonomy. I think from a biology point of view, it's not 100% accurate, but it does convey the job, right? So there are parts around our brain which are responsible for reasoning, which are responsible for memory, which are responsible for our sensory, aspects like interacting with the real world, right? So what people have started saying now, and a lot of people, experts like Andres Karpathy, have said that we actually are looking now again back to the biology, back to the human brain biology as inspiration on how to configure these AI agents, whether it's the way the brain works or it's our social behavior, and things like that. So that's becoming really interesting. Yeah. So the ChemPro thing, the tool that I showed you, right, where it was actually building molecules. So just to give like what a real project could look like, right? So here you've given it the input saying that I want to build like an insect repellent. I want to build odomos or something like that, right? It takes that and it has access to a huge number of tools, right? So it has tools like literature search, web search, code interpreter. It even has a human expert. So some place where it feels like it's getting stuck, it can pause and ask for a human expert input, right? But it is sort of automating a lot of those things, but it's also taking a human input because at some stage it needs that. Then it has some reaction tools that can help it understand, okay, if I mix this and this, what will happen, right? And then it has molecule tools which are like, okay, which basically tell it, what should be the weight, what is the price, etc. Right? And it also has some safety tools built into it, right? So you don't want someone to go and say, okay, hey, how do I build TNT, right? Because if you don't have these, it will actually give you a very precise way of building TNT. Right? So these are all the tools. It's the balance of what it needs to do plus CFE plus. So think of all the things that we've been discussing, how they could all fit in over here. Yeah. Okay. And then someone came up with this interesting thing. This is again a recent paper where it talked about, okay, one single agent is very powerful. So what if we put lots of them, and we actually say, can you debate? So there was this one paper which said debate and arrive at final answer, right? It said improving factuality and reasoning in large language models through multi-agent debate. And one other thing said pretty much the same work. It said introduce divergent thinking, right? So you again give them different personas and you say, okay, now think about this idea. So in this, what happens is you've given them a problem statement, right? And then in this case, we have two agents. So agent 1 solves first. We take that output and we give it to agent 2, saying that, okay, someone else has given this, you don't have to necessarily agree with this, but what do you think is the answer, right? So it goes and it takes what it has and it comes up with its response. Then we go to round 2, where it again goes through it, and then you go to round 3, where they both agree in the end. So they reach the consensus and this is sort of accurate. So this pattern seems extremely powerful, where you can put it against itself. And it's really exciting. Okay. So now this is my gyan, like my strong opinion weekly head. Okay. Where I feel that given enough iterations, like we talked about, like it takes 50 turns, right, to arrive at the right answer, but it could be 100, it could be whatever, right? Given enough iterations and given enough tools and memory, enough specialized tools, right? So you saw in the case of like that smiles and reactions and things like that, right? What if we gave it some more specialized other kinds of AI models, etc. Right? I feel that AI agents can do any task, any level of complexity with enough accuracy, right, to surpass what is whatever is our acceptable definition, right? But there is this constraint of time and cost, right? And there is another big aspect which we haven't covered till now, is about transparency. So when it's working, you don't know exactly how it's going. It's not thinking linearly like a human, right? All of us in our day jobs are used to a lot of autonomy, right? If I'm a developer, I write code, I write it in the way that I want. If I'm a lawyer, I'm reviewing some, documents, I have a particular SOP, right, in my head that I'm going through. So this does come at some cost of transparency and cost and things like that, but it's a very interesting space, and obviously people are like exploring it very deeply. Okay, so that's the end of pass 2. Is this okay? Still there? Yeah? Okay, so now we get to like the third pass where we'll actually look at code, right, and how we can build this. Yeah, sorry.
Just a quick question. Is there a way to handle defects? For example, like given it incorrect data, Of course, right? It could be intentionally, unintentionally.
Yeah.
Is there a way to walk back from there?
Yeah, definitely. So I think the question was like, if I've given an intentionally, unintentionally defected data, then is there a way it can backtrack? Like it makes a mistake and it backtrack basically. So there is, and just like this idea of self-criticize, etc., self-reflect, self-criticism, we can come up with other ways where it could do that, right? So just think of it as another step in the flow, right? And you can have some sort of gating mechanism and say, do you think this is all right? If yes, let's proceed. If not, repeat, right? So that's a very simple answer, but that's the intuition with which you would go with. Okay, so yeah, sorry.
So it's one question. Just go back to this problem. So I think ultimately what is usually with thinking of pattern recognition, any task, right? You see what is specified. There's some patterns you recognize, but there's some, path to it.
Yeah.
What about tasks with pattern recognition fail?
So actually, it's not learning. It's not doing what we do in deep learning and machine learning. It's not really looking at patterns, right? It's got a bunch of capabilities, and at every point in time, I'm saying this is the state of the world, and I can do these 10, 20 things. Which one should I do next, right? Which will make me move closer to the task. So that's why it's different from pattern recognition. So in the end, you don't even get a model as such which will learn something. It's got a bunch of artifacts. Like it's got memory of that I did this, right? Like for example, it can have, let's say, I'm giving a very simple example, but let's say shopping again, right? Amazon.com, and it can basically learn that UPI is faster than net banking, right? But it is not really learned it; it's just stored it in its memory. It's like a Word document somewhere saying
It's optimized for
some aspect.
Transaction time and set this
Yeah.
path is better than
Yeah.
that path. It is based on something better. Which was bounded by tools, right?
It's bounded by tools.
You can't do it.
It's bounded by tools, it's bounded by memory, it's bounded by how you constructed memory. Yeah, the token length. So ultimately the biggest challenge in all of this is context window. How much can you stuff into one go, right? So you have to prioritize what you need to do. In that Simulacra paper which we did, which was about those guys going for a Valentine's Day party. What they did was they were generating, if you go to the previous slide, so in this timestamp, like half an hour from 6 a.m. onwards, right, you have like 24 events that have happened, right? For each of the events, it's saying what were you doing, where are you, what are you saying. But then what they did was, this is too much to go into the memory also. So they started putting a decay factor, saying that the more recent you are, that will be shown on top. So that was one factor. Then the second one was, how important is this item to your code, right? So for example, I know the baker is here. There's a baker and his son's graduation was coming up next week, right? And they asked it, how important is this? It came back with a rating of 6. But there was something about like it has to place an order or something that was like 7. So basically saying his goal of building his restaurant is more important than his son's graduation, something like that. I'm forgetting the exact details. But you basically rank everything and then you compress it. Now this is what you remember, right? And then it can go through. Does that make sense? Okay, so now we can jump to some code. How am I doing on time?
Already you have answered about how it can rectify defects going back to the chain of thought. Even assuming that we have a huge context window where, for example, I started to build a good antibiotic like penicillin.
Yeah.
So I started at step 1, step 2, step 3, I went till 1000 steps.
Yeah.
One thing, what would my initial step has set me up into an entirely wrong direction. So how will you tackle the problem that through decay or like you said, like importance, right?
Yeah.
So there is always a possibility if we cross a global minima, we can reach a global maxima later.
Yeah. So at some stage, like some stage, so I'll give you like crude things, right? See, it will not always arrive at the right answer. It's very probabilistic. So at some stage, you will put in some other guardrails saying that don't use more than 10 steps, right? That after 10 steps, if you still not arrived at the answer, stop, or something like that, right? Or if you feel like the standard pattern in all of this is like for 3 times I'm calling the same tool with the same argument end, because that means we're stuck, right? So those are the ways. So what I'm saying is that this is not always going to get it right. Can this truly operate without human supervision? Not yet, but it's moving very fast where someone will figure out a way to set it up for your particular domain problem.
So is there a way, when you told that it can backtrack to the defect, is there any technical implementation which is already like it can go find the root cause why the previous process went into a loop and go back and start is there a way that we can do that now?
Yeah, so there is one thing that comes pretty close to this. It's called the reflection, but REFLEXION. Okay. What they did was, so they did basically this idea that there are multiple steps that I take to achieve the objective. But every once in a while they look at how many steps I took, like what was my trajectory, and then they rank that. They say, okay, this path was too long, so it gives it additional feedback. So like there's like this step that's happening, but then every 10th step or so they like comment and then they fix it. So I would say look at this paper called Reflection, REFLEXION, which basically solves for that.
Active R&D area.
Yeah, these are all active R&D areas.
So one more thing, be it defects and lot of human progress also happened, right? Because there were a lot of accidental discoveries.
Yeah.
Be it penicillin, be it fire.
Yeah.
So are these agents are capable currently, or is there a way where you are trying to build something through the chemical
Chemgrow, yeah.
But during that route it found some composition which is great for something else.
Yeah.
Can it really detect and go deviate from the goal which is given?
Yeah. So
Kind of capability is it there now?
I mean, okay, so I didn't build Chemgrow, right? But basically the thing is that it will meander a lot. See, when you look at how they run, sometimes you think like this is completely fallen off track, right? And it's going to end in nothing, and then suddenly you're surprised, oh, it's got back on track. So there is a lot of variability. It's not rock solid, right? And that's again an active area of discovery. Okay, cool. So 10 minutes, we'll quickly move on. Okay, so I thought let's just do a quick demo on like looking at actual code, and I tried to sort of think about what would be the lowest common denominator. And I thought about a problem statement that my father-in-law grapples with every day, which is like he's unhappy with his wealth manager. So I said, could we try and build that, right? So can we think about building a very simple wealth manager, which is someone who can read your latest reports, right, and provide some commentary on it. Someone who can do some data analysis on my transaction history, right, and fetch current price. And then imagine this last part where we were talking about agents debating. Could I have someone like Warren Buffett think about my decision? Right? So I've implemented a very, very simplistic thing just to sort of show you the structure, and obviously we can go very deep in this. Yeah. So I'll do this. Okay. So what I have over here is, I'll show you a prompt because I think all of us understand prompts. So if you can read this, it says, you run in a loop of thought, action, pause, observation, right? This is what we're telling the AI agent. At the end of the loop, output your answer. Use thought to describe your thoughts. Yeah, so use thoughts to describe your thoughts about the question you've been asked. Use action to run one of the actions available to you. Then return pause. Observation will be the result of running those actions, right? And what you have available is like a calculator, you have some Wikipedia, and I have given it this knowledge base, right? And I said always look things up on this knowledge base if you have the opportunity to do so, right? So here's an example of how this would work. Right? If we ask it the question, what is the capital of France? Then it will say I should look up France on Wikipedia, and then that will lead to this triggering this action or this tool called Wikipedia and say France. It will wait for the result to come, and then it'll get back this thing that France is a country, the capital is Paris. Now it has all the information, and then you'll get the answer of this. So this is what it's doing. Okay. Now what I'm going to do is, to prevent any embarrassments, I've actually put down my thing. Hopefully it works. So over here what I've said is that what are the highlights of Tesla's latest, yeah, it still fails even after all that. Okay, so I asked it, can you describe, what is the latest, what are the highlights of the last quarter earnings, right? So this went a little fast. Basically what it did was, it took that question and it said, okay, obviously I don't have the knowledge, right? I should check Tesla's latest quarterly earnings. So it goes to the knowledge base, right, where I have a vector database which has all this information, and it gets back relevant paragraphs from there, right? These are across say 5-6 articles or whatever, and it puts this into the GPT summary, and then it generates this sort of summary, right, for me. So according to the knowledge base, blah blah, all of this, right? So pretty simple. It can do this. Now we'll make it a little more complicated. Yeah, why does it say poetry? So poetry is my package manager, but it's got nothing to do with this. It's just a simple thing. Okay, so now I've asked it the question saying how much Tesla do I own? What's the total value of my position, right? So it says, okay, I need to check the user's transaction history to determine how much Tesla they own and calculate. So it calls another tool called transactions, right, which will return this table. And then it will call calculator to do all of the math, right? And then it will call what is the price of Tesla, I'll get this. And again it will call the calculator and I'll do this, and I will say you own these many shares. I don't own those many shares of Tesla. This is all generated by GPT, right? Yeah, is this okay? Or we can drill down if you have some questions on this. No?
No cells, only buy.
There are some cells actually, so there is that error that it's forgot to subtract the sales. Yeah, and then there's this other thing that I tried to do, which was is Tesla overpriced right now, right? So what it does is it says, okay, what's the price to earnings ratio of Tesla, and it gets that PE ratio. Okay, so it comes up with this. Sorry, it broke, but I'll just quickly cover what I was trying to show. That it says that this is the PE ratio. It got it from Yahoo Finance, right? Pretty easy to do. Then we sent it to Warren Buffett and we asked it for its opinion, right? And it comes back with that line. Okay, so I can just quickly show you what that looks like. So the prompt, is fairly simple, right? Where we have told it, look, there's a knowledge base, there's a transaction history, right? There's a price, you can get the current price, there are ratios, and we've also said there's a critic, right? Returns a response by an expert to validate the final decision, right? And in my tools, what I've done is that I have given it these basic tools. I'll show you price, which is very easy to understand. So price is this tool where it gets a stock code and then it calls Yahoo Finance and will return that particular price, right? So this is giving that Tesla share price. In the case of ratios, what I've done is actually really simple. I've said, so I get only a string. I get this information, like get the PE ratio for Tesla, right, with some financial ratio. So I call ChatGPT and I say, get the stock code from the question. Like, what is the code? Is it Tesla or whatever? So it gets me that stock code. Then I get the information, right? I again give GPT this information, this entire dump. It's like a big JSON. And I say, answer user's query, and it returns that result, right? So like, this is an example of what it does. Like, what is the price to earnings ratio of Amazon? It will take out Amazon from this and then pull out whatever we want. I'll show you a critic because that was fun. So in the critic's case, they get a decision which says that this is what the decision is, right? So I said you're an expert investor of the caliber of Warren Buffett. You're a long-term buy and hold thing. You're always looking for great value points. Evaluate the advice the user has received. Give your feedback as to whether the advice is good or bad, right? And return it in this format of, it's good or bad and the reasons, right? And this is all that there is. It comes back with, information. So this is what it's saying that according to the expert critic, the high price of earnings ratio, and therefore it may be overpriced and stuff. So fairly simple, code. Any questions here? Okay, cool. Yeah.
How does it determine which is the correct web address, the correct URL?
So that we've given it code, right? We said go to Yahoo Finance and get the code. That's what I was saying. Yeah. So we've given it that information. Yeah.
So this was, I'm presuming this was a couple of hours or?
Yeah. This was this one.
This morning.
Yeah.
So if you, and obviously it's bounded again by 2. So if you added sort of more to it.
Yeah. You do more.
At how many weeks or days would you think would take to, on a probabilistic basis, right, be as confident as a
actual
confident as a. And what's that learning? Because you could say, hey, it's not just price earnings ratio, here all the ratios you could give
It actually has all those
all
ratios.
those, you could give it sort of the ways to compare ratios
Yeah,
with
yeah,
other tools,
yeah.
and with specify one.
Yeah.
This should be obviously informed by me.
So I don't know. My intuitive sense is like, yeah, if we get like another 10 days or so of active development, we can get very far. But we also need feedback, right? We also need a user, and you need to keep modifying it based on how they are using it, right?
And the big question here is, what happens the 10th time or the 9th time when it goes crazy? Or
Yeah.
gives you a
Wrong answer.
more problems.
No, so that will happen anytime, right? So use it with caution. I mean, so we need to build in some sort of self-correction, self-evaluation also.
Or a multi-agent model to say this answer is particularly bad.
Yeah. So that's what I'll try to do with the critic, right? To say, okay, this is what I want to do, but then have like 2-3 different philosophies, like a buy and hold philosophy, and then the other one which is like, let's maximize the returns kind of thing, and then see. Yeah. So I'll just quickly end very quickly on a little note on Microsoft research, which I want to share. So we're very excited about obviously exploring about AI and global south. We look at our impact around 3 axes, which is impact to science, impact to business, and impact to society. A lot of the projects that I work on are at the intersection of science and society, right? And some of these efforts we actually graduate. So these can no longer be research projects. They've hit some amount of critical scale. So we hand them over to NGOs, social enterprises, governments, and spin-offs. We do spin-offs. And related to that, this happened like 2 days ago. This is not my project. But it's very exciting where one of the projects that was spun out from the lab called Karya made it to the Time magazine cover, right? Which is incredible. This is all about ethical AI data collection from the field, where they collect the data so people can digitize data, either text to speech, text to text, etc., multilingual data. And then what Karya is trying to do is get them to own some of this data. So they get royalties as the models evolve, they continue to. Otherwise, the other practices are pretty exploitative. Right? So there's this great article you should definitely read. I put a quote from one of the beneficiaries, but in the interest of time, I'll skip. And if we also run a fairly interesting research fellow program, a lot of people from computer science apply, but people in other disciplines can also apply. This is just for people who, students in the room, right, who could benefit from this. It's a 2-year program, and people go on to do PhDs or also startup and things like that. Like an interesting fact, Bhavesh Agarwal of Ola was an RF at Microsoft Research. Yeah.